Hello to all operations and maintenance directors, wind engineers, and digitalization managers. In this video, we'll explore a transformative vision for wind farm management. We'll delve into the concept of a wind farm that not only generates energy, but also thinks and coordinates intelligently. The central idea is simple yet revolutionary. A wind farm operates as a living organism. Its turbines are not isolated entities, but interconnected components of a larger system. This collective approach maximizes efficiency and profitability. In this video, we will attempt to clarify how the orchestrating agent works. We will explain some of the associated subagents, their coordination and optimization capabilities, and their dynamic response to the market and the grid. This agent is, in essence, the brain of the entire central nervous system of the wind farm. The orchestrating agent is like the digital brain of a smart wind farm. It is the entity that provides thought and decision-making power to the set of wind turbines. Its function is to transcend mere supervision. This digital brain can be implemented in a variety of ways. It can reside in the cloud, taking advantage of scalability and distributed processing. Alternatively, it can operate at the edge of the network, ensuring minimal latency and ultra-fast response. It is crucial to differentiate the orchestrator agent from a traditional SCADA system. A SCADA is primarily a visualization and monitoring tool. It offers historical data and enables reactive control, but lacks proactive intelligence. The orchestrator agent goes far beyond visualization. It analyzes thousands of signals in real time, covering production, weather conditions, and market prices. It also considers the status of the electrical grid. This advanced analytical capability enables proactive and optimized decision-making. The orchestrator not only reports on what's happening, but also acts to improve performance. Its intelligence lies in anticipation and adaptation. The power of the orchestrator agent lies in its coordination capacity. It achieves this through a network of specialized subagents. Each subagent focuses on a critical dimension of the park's operation. We identified 5 key dimensions that define the orchestrator's power. These areas of action are fundamental to intelligent management. Together, they transform the park's operation. The first dimension is the aerodynamic optimization of the entire fleet. This involves collectively adjusting the turbines to maximize wind capture. The goal is to achieve overall, not just individual, efficiency. The second is the intelligent response to the electricity market. The orchestrator adapts production to price fluctuations. This ensures maximum profitability at all times. The third dimension is the coordination of critical alarms and grid compliance. The system ensures operational stability and security. It responds proactively to unexpected events. The fourth is advanced visualization through a digital twin. This virtual representation allows for a deep understanding of the park's behavior. It facilitates simulation and strategic planning. The fifth dimension is fluid communication with the rest of the multi-agent system. This interconnection is vital for decision execution and enables cohesive and efficient operations. The orchestrator agent applies its intelligence in real-life scenarios. These cases demonstrate its ability to optimize and react. They illustrate its strategic and technical thinking. The first case is aerodynamic optimization, known as the wake effect. One of the biggest problems in wind farms is the wake effect. Turbulence generated by the front turbines significantly reduces the output of the rear ones. The orchestrator agent addresses this challenge intelligently. It analyzes wind direction and speed in real time, taking into account the relative position of each turbine within the farm. It also evaluates the expected performance of each wind turbine. With this information, the orchestrator identifies the turbines affected by wake turbulence. Its goal is to mitigate this detrimental effect. The orchestrator's solution is innovative and precise. It orders a slight reorientation, or yaw, of some turbines. This small deviation is not intended to maximize individual turbine output. Instead, its purpose is to deflect the turbulent wake. By doing so, the wind reaching downstream turbines is cleaner and more powerful. This maximizes the farm's total energy generation. The result is a significant increase in collective output. This is achieved without adding additional hardware, only with intelligent management. It also reduces mechanical loads on the turbines. The second advanced use case focuses on production strategy. The orchestrator agent responds dynamically to electricity market conditions. Its objective is to maximize profitability. Let's consider a scenario where the price of electricity in the spot market drops drastically. Producing energy under these conditions could result in economic losses. The orchestrator detects the situation. Faced with this price drop, the orchestrator agent makes a strategic decision. It can order a reduction in energy production. This avoids selling electricity at an unprofitable price. If the park has energy storage systems, such as batteries, the orchestrator can go further. Instead of reducing production, it can order the storage of the generated energy. This energy will be sold when prices are more favorable. Another intelligent action is maintenance rescheduling. If there are pending maintenance tasks, the orchestrator can advance or delay their execution. It chooses the lowest price time to minimize opportunity costs. This market adaptability transforms information into economic value. The orchestrator agent ensures that the farm not only produces energy, but does so in the most cost-effective way possible. The following example allows the orchestrator to respond to critical grid events. Grid stability is paramount. Wind farms must contribute to it, not just inject energy. Imagine a scenario where a sudden drop in grid frequency or voltage is detected. This is a critical event that requires an immediate response. The orchestrator agent identifies it immediately. In this situation, the orchestrator takes control of the farm's operation. Its priority is to stabilize the grid and comply with grid codes. It acts in a coordinated and precise manner. It adjusts the turbine's active and reactive generation. Active generation refers to real power, while reactive generation helps maintain voltage. These adjustments are crucial for stability. It also activates smooth power ramps. This avoids abrupt changes in energy injection that could further destabilize the grid. The transition is controlled and gradual. It can also reconfigure the turbine inverters. This reconfiguration optimizes their behavior under grid conditions, ensuring an appropriate and robust response. The orchestrating agent actively collaborates with the parameters set by the electrical system operator. Its coordinated action helps stabilize the grid, demonstrating its vital role in ensuring the security and reliability of supply. The orchestrating agent is not an isolated entity. Its intelligence resides in a modular architecture of specialized subagents, each of which performs a specific and vital function. There is one subagent responsible for collective aerodynamic efficiency. It determines the optimal yaw angle, yaw, and blade angle, pitch, for each turbine. Its objective is to maximize the group's performance. It receives and processes real-time data from the environment. This includes wind direction and speed, as well as turbulence. It also considers the mechanical loads on the turbines. In addition, it assesses the health status of each wind turbine. With all this information, the subagent calculates the ideal configuration. This configuration ensures maximum combined production and minimizes mechanical stress. The market strategy subagent is the economic brain of the wind farm. Its role is to optimize the profitability of the energy generated. To do so, it constantly monitors the market. It reads spot electricity prices in real time. It analyzes existing power purchase agreements, PPAs. It also incorporates weather forecasts that affect production. With this information, it proposes economic adjustments to the operation. It may suggest reducing production during times of low prices or recommend storing energy to sell during peak demand. This subagent is the park's cognitive interface. It maintains a real-time digital twin of the park. This virtual representation is an exact and dynamic replica of the physical facility. It allows operators to visualize the park's current behavior. It also simulates responses to changes in weather or the grid. This facilitates informed decision-making. The digital twin allows operators to see the park's future potential. They can test different scenarios and strategies. It is a powerful tool for planning and optimization. This subagent is the guardian of stability and security. It monitors compliance with all technical requirements of the grid, including frequency, voltage, and power ramps. It executes predefined protocols in the event of critical global alarms. It coordinates emergency shutdowns or soft power ramps. Its action is vital to avoid interruptions and protect the infrastructure. It ensures that the fleet operates within the limits established by the grid operator. Its rapid and automated response minimizes risks. It contributes to the reliability of the electrical system. The orchestrator agent acts as the central node of a complex communication network. It interacts with various specialized agents. This interconnection is essential for the execution of its decisions. The orchestrator communicates with the wind turbine control agent. It sends commands to adjust the pitch and yaw of the blades. It can also activate or stop turbines or program silent modes. It receives information from the environment and prediction agent. This agent anticipates wind gusts, changes in direction, or the formation of ice. This forecast allows the orchestrator to act proactively. It interacts with the intelligent maintenance agent. The orchestrator requests the optimal window for performing maintenance. The objective is to minimize economic losses during shutdowns. The technical knowledge capture agent is crucial. It incorporates suggestions and best practices from field personnel. This continually improves the farm's operation. The continuous learning agent adjusts the orchestrator's decision models based on new patterns and historical data. This ensures that the system evolves and improves over time. Finally, the data and communications agent manages the transmission of information. It ensures that data flows in real time and securely. It is the backbone of connectivity. The result of this network is transformative. It turns the wind farm into an intelligent and coordinated asset. Each component contributes to overall efficiency and profitability. The implementation of the orchestrator agent represents strategic importance. It is not just a technical solution, but a competitive advantage. It redefines the management and performance of wind asset management. In 12 months of operation, the expected results are significant and quantifiable. A substantial improvement in production and efficiency is observed. This data validates the investment in intelligence. An average increase of 6% in total production is projected. This is achieved without the need for hardware changes. It is a pure increase in operational efficiency. Unplanned downtime hours are reduced by 30%. This is due to better event and maintenance management. The reliability of the wind farm is significantly improved. Recurring critical alarms decrease by 20%. The orchestrator's ability to anticipate and mitigate problems is key. This reduces operational burden and risks. The park's economic efficiency increases by 12%. This improvement is a direct result of intelligent market response. Energy is sold at the most profitable times. Return on investment, or ROI, is achieved in less than 18 months. This rapid payback demonstrates the economic viability of the solution. It is an investment that quickly pays for itself. The fundamental principle of the orchestrator agent is clear. It turns information into action, and that action translates directly into operational benefit. It is intelligence at the service of profitability. In short, the orchestrator agent functions as the brain of a smart wind farm. It is the central piece that coordinates, optimizes, and adapts the operation. It transforms a set of turbines into a unified organism. Its ability to integrate data, make proactive decisions, and respond to critical events is unmatched. It enables farm management that goes beyond traditional monitoring. It is the key to the next generation of wind energy. In our next video, we will delve into the local intelligence of each wind turbine. We will explore how intelligence is distributed down to the individual turbine. We will analyze predictive maintenance and inter-turbine cooperation.